Imagine standing at the edge of the ocean. The water stretches before you, endless and dark, catching the last light of a fading sun. Waves move slowly, almost breathing. The air smells of salt and ancient things. You have stood here before, perhaps, at the edge of the sea, looking out. But tonight, we are not going to stand at the edge. Tonight, we are going in, not just to the surface, not just to the shallow, sun-warmed waters where coral reefs glow in turquoise light and schools of fish move like living silver through the current. We are going deeper, much deeper, down past a place where sunlight fades, down past a place where pressure begins to build, slow and immense, like the weight of the sky made liquid, down into a place that covers more of this planet than all its continents combined, and that we know less about than the surface of the moon, the abyss, the deep ocean, the last great unknown on the face of the earth. And it is not empty. It is not silent. It is alive in ways that will change how you think about life itself. So let the day go. Let the weight of it fall away from you, gently, like sediment drifting down through still water. Close your eyes, if you wish, and come with me. Down. Chapter 1. The world beneath the world. Most of us think of the ocean as a surface, a place where boats move, where waves rise and fall, where the horizon meets the sky in a clean, familiar line. But the ocean is not a surface. The ocean is a volume, an almost incomprehensible volume of water, covering 71% of this planet, reaching depths of nearly 11 kilometers in its deepest point, holding 97% of all the water on Earth. If you took every mountain on this planet and placed them one by one into the deep ocean, they would disappear without a trace. The average depth of the ocean is 3,600 meters. That is more than 3.5 kilometers of water, pressing down in every direction, with a force that would crush an unprotected human body in seconds. And yet, life found a way. Not just found a way, thrived, diversified, invented solutions to problems that nothing in the history of biology had ever faced before. The deep ocean is not a wasteland. It is one of the most biologically diverse environments on Earth. We have explored less than 20% of it. What we have found in that 20% has rewritten our understanding of what life is, what it needs, and what it can become. Chapter 2. The zones of darkness. The ocean does not simply become dark all at once. It darkens in layers, in zones, each one more remote, more silent, more extraordinary than the last. The first zone, the one closest to the surface, where sunlight still reaches, is called the sunlight zone, or, in the language of oceanography, the epipelagic zone. It extends from the surface down to approximately 200 meters. This is the ocean most of us know. The bright, warm, teeming world of coral reefs and whale migrations, and the great schools of fish that move through equatorial waters like slow-moving rivers of silver. Beautiful, familiar, well-studied. Below it, the light begins to fail. Between 200 and 1,000 meters lies the twilight zone, the mesopelagic. Here, sunlight filters down in faint blue-green columns, growing dimmer with every meter. Enough to see by, barely. Not enough to support photosynthesis. The creatures that live here have adapted in extraordinary ways. Eyes enormous beyond proportion to catch every photon of the fading light. Bodies transparent as glass, offering no silhouette for predators to track in the dim water. Bioluminescent, living light, produced chemically within the body itself, used for communication, for hunting, for the strange social rituals of a world without sun. below 1,000 meters. Darkness. Complete. Absolute. The kind of darkness that has no equivalent on land. This is the midnight zone, the archipelagic, a place where the concept of day and night has no meaning, because the sun has never reached here and never will. A place of almost unimaginable pressure, hundreds of atmospheres bearing down on every surface. And below that, lies the abyssal zone, the place that gives the deep ocean its oldest name, the abyss. Chapter 3. The abyssal plain. If you could somehow travel to the bottom of the deep ocean, not to a trench, not to a seamount, but to the vast, flat expanse of the abyssal plain, you would find yourself in one of the strangest landscapes on Earth. Flat, featureless, almost to the human eye. Covered in a deep layer of sediment, fine particles of clay, and the skeletal remains of countless tiny organisms that have been drifting downward, slowly, for millions of years. Scientists call this material marine snow, and it is, in its quiet way, one of the most important processes on the planet. The slow, continuous fall of organic matter from the surface world to the deep, carrying carbon, carrying nutrients, feeding an ecosystem that has never seen the sun. The temperature at the abyssal plain hovers just above freezing, 1 or 2 degrees Celsius. Cold in a way that is not dramatic, not the sharp cold of a winter morning, but deep and still and absolute. The pressure at 4,000 meters is 400 times the pressure at the surface. The weight of 400 atmospheres pressing inward from every direction simultaneously. And in this cold, dark, crushing environment, life, not the sparse, struggling life of a hostile environment, but genuine, complex, adapted life. Creatures that have lived in these conditions for so long that they would die if brought to the surface. Creatures for whom the abyss is not a hostile place, but home. Sea cucumbers, moving slowly across the sediment, processing mud for the organic particles it contains, leaving long trails behind them, like the tracks of ancient, unhurried travelers. Brittle stars, relatives of starfish, their long, sinuous arms moving through the sediment with a slow, hypnotic grace. And in the sediment itself, invisible to the naked eye, but present in almost unimaginable numbers, microbial communities living on chemical energy, photosynthesis irrelevant, sunlight unknown, thriving in conditions that would have seemed, before we found them, incompatible with life. Chapter 4. The light in the darkness. There is something you need to know about the deep ocean. It is not dark, not entirely, not in the way that a room with no windows is dark, a passive absence of light. The deep ocean makes its own light. Bioluminescence, the production of light by living organisms, is not a rare or unusual phenomenon in the deep sea. It is, in fact, the dominant mode of communication, hunting, and signaling in the world below the sunlight zone. Scientists estimate that 76% of deep-sea creatures produce some form of bioluminescence. Think about that number. More than 3/4 of all life in the deep ocean carries its own light. The mechanisms vary. Some creatures produce light through chemical reactions within specialized cells called photophores, tiny organs scattered across their bodies like embedded stars. Others harbor bioluminescent bacteria, providing them with shelter and nutrients in exchange for the cold blue glow they produce. The purposes are as varied as the creatures themselves. Counter-illumination, producing a faint glow on the belly that matches the dim light filtering down from above, making the creature invisible to predators looking upward. Lures, the famous dangling lights of the anglerfish, swaying gently in the darkness, mimicking the movement of smaller, bioluminescent organisms, drawing curious prey close enough to catch. Communication, flashes and patterns is used between members of the same species. A language written in light in a world where sound travels differently, and chemistry moves slowly. Defense, the sudden burst of brilliant light from a threatened creature, startling a predator long enough to allow escape, or the release of bioluminescent fluid into the water, a glowing cloud that confuses, that marks the predator for other predators to see, that turns the advantage momentarily, surprisingly, around. If you could somehow float in the water of the midnight zone, weightless, pressurized, impossible as the thought is, and turn off your own lights entirely, you would not be in darkness. You would be surrounded in every direction by the slow, cold, living light of 10,000 creatures going about their ancient business. A sky made of organisms, a darkness full of stars. Chapter 5. The hydrothermal vent. In 1977, a research submersible named Alvin descended to the seafloor near the Galapagos Islands and made a discovery that changed biology forever. On the floor of the ocean, in a place where two tectonic plates were slowly pulling apart, superheated water was venting from the seafloor. Water that had percolated down through cracks in the ocean crust, been heated by the magma beneath, and returned to the ocean carrying dissolved minerals, sulfur compounds, methane, hydrogen, in concentrations that should, by the understanding of the time, have been completely hostile to life. And around these vents, life. Not sparse life. Not isolated bacteria clinging to a hostile surface. Lush, extraordinary, almost tropical abundance. Giant tube worms, Riftia pachyptilla, up to 2 meters long, clustered in dense communities around the vent openings, their bright red plumes swaying in the superheated current. Creatures with no digestive system at all, sustained entirely by symbiotic bacteria living within their tissues, converting the chemical energy of hydrogen sulfide into the organic compounds their hosts needed to live. Pale crabs, white shrimp, fish unlike anything seen at the surface, an entire ecosystem, complete, self-sustaining, utterly independent of sunlight. For the first time in the history of science, life had been found that did not depend, directly or indirectly, on the sun. The implications were profound. If life could thrive here, in complete darkness, at crushing pressure, in water laced with chemicals that would be toxic to surface life, then the conditions we had always considered necessary for life were not necessary at all. They were simply the conditions that life had found on the surface of one small planet. Somewhere else, on the ice-covered ocean of Europa perhaps, or in the subsurface waters of Enceladus. Other vents might exist, other ecosystems, other forms of life, built on the same chemistry of darkness and heat and chemical energy, knowing nothing of stars, nothing of sunlight, nothing of the universe above them. Alive, nonetheless. The discovery of the hydrothermal vents did not just change our understanding of the deep ocean. It changed our understanding of life itself. Chapter 6. The Creatures of the Abyss. Let us spend a moment, a quiet, unhurried moment, with some of the creatures that call the deep ocean home. Not the terrifying ones, not the sharp-toothed nightmare visions that populate the darkest corners of our imagination of the deep. The real ones, the extraordinary, patient, ancient, remarkable real ones. The Dunbar octopus, Grimpotatis, lives at depths of up to 4,000 meters. It takes its common name from the two large ear-like fins fins that it beats slowly and continuously, hovering just above the seafloor, with a grace that seems improbable for something so round, so soft, so entirely without pretension. It moves through the darkness like a thought, like something half remembered. It is the deepest living octopus known to science. The fang-toothed fish, Anaplogaster cornuta, has, relative to its body size, the largest teeth of any fish in the ocean. They are so large that the fish cannot close its mouth completely. The lower fangs fit into special sheaths alongside the brain when the jaw is shut. In photographs, it looks terrifying. In the ocean, it is 4 centimeters long. A creature of the midnight zone, hunting in complete darkness, using its extraordinary teeth to catch prey it cannot see, relying on the faint bioluminescent traces, the pressure waves of movement, the chemosensory information carried by the cold water. Patient, precise, ancient. The vampire squid, Vampiroteuthis infernalis, is neither a true squid nor a true octopus. It occupies its own order, its own branch of the cephalopod family tree, a living relic of an older evolutionary lineage. Its name comes from its dark coloration and the webbing between its arms, a cloak of flesh that it can wrap around itself when threatened, becoming a dark sphere in dark water, nearly invisible. But the vampire squid is not a predator. It feeds on marine snow, on the slow, endless drift of organic particles falling from the world above. It spreads its arms in the water, trailing long filaments that catch the drifting particles like a net cast in falling rain. A creature named for a monster, living quietly in the dark, eating snow. Chapter 7. What the deep ocean tells us. We are near the end of our journey tonight. Before we return to the surface, to the air and the light and the familiar weight of a world that fits our bodies, I want to linger for a moment in the cold and the dark and think about what all of this means. The deep ocean covers more of this planet than any other environment. It contains more living space than all terrestrial environments combined. It has been continuously inhabited for hundreds of millions of years, longer than the continents have held their current shapes, longer than the dinosaurs lived, longer than almost anything else in the history of complex life on Earth. And we have explored less than 20% of it. What is in the other 80%? We genuinely do not know. We have found ecosystems that require no sunlight, creatures that produce their own light, life forms that have solved the problems of pressure and cold and chemical toxicity in ways that have no parallel anywhere else on Earth. We have found, in the deep ocean, a reminder that life is not fragile. It is not a rare, precious, easily extinguished thing that requires exactly the right conditions in exactly the right proportions to exist. Life is tenacious, inventive, relentless. It finds a way into every corner, every crevice, every environment that offers even the smallest possibility of survival. It has been doing this for 4 billion years. It is not finished. Chapter 8. Returning to the surface. It is time to come back. Slowly, gently. The word diver ascends through the water column, pausing at each depth to let the body adjust, not rushing, letting the pressure equalize at its own pace. From the abyssal plain, rising through the midnight zone, the darkness unchanged, the pressure incrementally releasing. Through the twilight zone, where the first traces of blue-green light begin to filter down from above. Not sunlight yet, not warmth, but the suggestion of a world where the sun exists. And then, the surface, the shimmer of light on water from above, the world you came from, waiting. Sleep sequence. Let your body be still now. Feel the weight of it, the solid, comfortable weight of a body that has traveled far tonight, through darkness, through cold, through the deepest places on earth. It is allowed to rest. Let your shoulders settle. Let your jaw release. Let the thoughts of the day, the small worries, the unfinished tasks, the conversations that replay themselves in the quiet of the evening, let them drift, like marine snow, falling slowly, gently, down through still water, settling, softly, on a distant floor. Gone. Chapter 9. The Mariana Trench. There is a place on this planet that has been visited by human beings fewer times than the surface of the moon. A place so remote, so inaccessible, so fundamentally hostile to human life, that reaching it requires technology as sophisticated as anything we have ever built. It lies in the western Pacific Ocean, east of the Mariana Islands. It is called the Mariana Trench, and it is the deepest place on Earth. At its deepest point, a location known as Challenger Deep, the ocean floor lies nearly 11 kilometers below the surface. 11 kilometers. To put that number in perspective, if you took Mount Everest, the highest point on the surface of the Earth, its summit reaching nearly 9 kilometers above sea level, and placed it at the bottom of Challenger Deep, its peak would still be more than 2 kilometers beneath the surface of the ocean. The Mariana Trench would swallow the tallest mountain on Earth and leave room to spare. The first human beings to reach Challenger Deep descended in 1960. Their names were Jacques Picard and Don Walsh. Their vessel was a bathyscaphe, a deep diving craft called the Trieste. It took them nearly 5 hours to descend. The pressure at the bottom was more than 1,000 times the pressure at the surface. When they arrived, they found a flatfish lying calmly on the sediment, moving slowly, alive, in the deepest place on Earth, in conditions that should, by every understanding of biology available at the time, have been completely incompatible with complex animal life. A fish, going about its business, as if the crushing pressure and the absolute darkness and the 11 kilometers of water above it were simply the world, simply home. The sediment at the bottom of Challenger Deep is unlike sediment anywhere else on Earth. It is extraordinarily fine, almost like powder, composed largely of foraminifera, the microscopic skeletal remains of tiny marine organisms that have been drifting downward from the surface for millions of years. When the Trieste touched down in 1960, it disturbed this sediment. A cloud of fine particles rose slowly around the craft. Particles that may not have moved since they settled, centuries or millennia ago. Time moves differently at the bottom of the Mariana Trench. Not literally, not in the way of physics, but in the way of quietness, of stillness, of a place so removed from the turbulence of the surface world that the ordinary rhythms of weather and season and tide barely register. And down there, in the deepest dark, time feels patient, ancient, unconcerned. Chapter 10. The Giants of the Deep. The ocean has always produced giants, not metaphorical giants, not creatures that seem large by comparison to something small. True giants, animals of a size that strains the imagination, even when you are looking directly at them. The deep ocean, in particular, has a phenomenon that scientists call deep-sea gigantism, the tendency of certain species to grow far larger in the deep ocean than their shallow water relatives. The reasons are not entirely understood. Cold temperatures slow metabolism, which may allow animals to live longer and therefore grow larger. The scarcity of food in the deep ocean may favor larger body size, which allows for longer fasting periods. Reduced predation pressure at depth may remove one of the main constraints on body size. Whatever the reason, the results are extraordinary. The giant isopod, Bathynomus giganteus is a crustacean, a relative, distantly, of the pillbugs you might find under a rock in your garden. Those pillbugs are perhaps a centimeter long. The giant isopod reaches lengths of up to 45 centimeters. It lives on the abyssal plain, scavenging the remains of larger animals that sink to the seafloor. It can go without food for extraordinary periods. Years, potentially. Its slow metabolism allowing it to wait, patient and still, in the darkness. When food arrives, a whale fall, a large fish, anything substantial enough to reach the bottom, the giant isopods gather. Dozens of them, moving with surprising speed for creatures usually so slow, consuming everything they can, and then returning to their patient waiting. The colossal squid, Mesonychoteuthis hamiltoni, is the largest invertebrate on Earth. Not the giant squid, which is longer. The colossal squid, which is heavier, bulkier, more massive. It lives in the deep waters of the Southern Ocean, around Antarctica. Its total length may reach 14 meters. Its eyes, the largest eyes of any animal on Earth, can reach 30 centimeters in diameter. 30 centimeters. Eyes the size of dinner plates, designed to gather the absolute maximum amount of light in an environment where light barely exists. We have never seen a living colossal squid in its natural habitat. Everything we know about it comes from specimens found in the stomachs of sperm whales, from individuals that have washed ashore, from the occasional creature brought up accidentally in deep water fishing nets. It lives its entire life in darkness we have never truly visited, moving through cold water, hunting with those extraordinary eyes, crossing distances we can barely track, alive, present, completely beyond our observation. The sperm whale, not a deep sea creature exactly, but a creature that crosses the boundary between worlds more completely than almost anything else alive, dives to depths of over 2 kilometers in search of its prey. It holds its breath for up to 90 minutes. In the darkness below the sunlight zone, it hunts giant squid, following the sounds of their movement through water, using the most sophisticated biological sonar system ever evolved. The clicks of a hunting sperm whale travel for kilometers through the ocean. They bounce off objects, return, are processed by a brain the size of a basketball, the largest brain of any animal that has ever lived, into a three-dimensional image of the water around it, seeing with sound, in the dark, at 2 kilometers depth, for 90 minutes at a time, and then returning to the surface, breathing, resting, diving again. A creature that lives simultaneously in two worlds, the sunlit surface and the crushing dark, more completely at home in both than we will ever be in either. Chapter 11. The Whale Fall. When a whale dies in the open ocean and sinks to the seafloor, something extraordinary happens. Scientists call it a whale fall, and it is one of the most remarkable ecological events in the deep ocean. The body of a large whale, a blue whale, a sperm whale, a fin whale, represents an almost incomprehensible quantity of organic material arriving suddenly in an environment where food is normally extraordinarily scarce. A single large whale carcass may contain 50 tons of organic matter. 50 tons delivered at once to the seafloor. In the deep ocean, this is an event of almost catastrophic abundance. The colonization of a whale fall happens in stages. Each stage lasts for years, sometimes decades. Each stage supports a different community of organisms. The first stage, the mobile scavenger stage, begins within hours of the whale's arrival on the seafloor. Sleeper sharks, hagfish, rat-tail fish gather in numbers that can reach hundreds of individuals. They consume the soft tissue rapidly, stripping the carcass to the bone within months. The second stage, the enrichment opportunist stage, sees the arrival of smaller organisms, polychaete worms, crustaceans, mollusks. They colonize the bones and the surrounding sediment, consuming the remaining organic material and reproducing in the sudden abundance. The third stage, the sulfophilic stage, is the most extraordinary. As bacteria begin to break down the lipids stored in the whale's bones, they produce hydrogen sulfide, the same chemical compound that supports the hydrothermal vent ecosystems. And around the whale fall, a miniature vent community assembles, the same specialized organisms, the same chemical processes, the same extraordinary life, built on sulfur chemistry in complete darkness. A whale fall can support a unique ecosystem for decades. Some researchers believe that whale falls may have served over the course of evolutionary time as stepping stones, islands of chemical energy on the otherwise sparse abyssal plain, allowing the specialized organisms of hydrothermal vents to disperse across the ocean floor, colonizing new vents as old ones went cold. The death of a whale feeds a world for years, for decades, in the dark, patient, extraordinary economy of the deep ocean. Nothing is wasted. Nothing. Chapter 12. The history of exploration. We have been exploring the ocean for as long as we have been human, but for most of that history, we were exploring the surface. The deep ocean, the true deep, below the sunlight zone, below the reach of the longest rope, was beyond us, unknown. Imagined sometimes, feared, often, but not visited, not real, in any practical sense, until very recently. The first systematic attempt to understand the deep ocean came in the 1870s. A British naval vessel called HMS Challenger departed Portsmouth in December 1872 on a voyage that would last 3.5 years and cover nearly 70,000 nautical miles. Its mission was to take systematic measurements of the ocean, its depth, its temperature, its chemistry, its biology, at regular intervals across the world's major ocean basins. The scientists aboard used a simple but laborious method for measuring depth. They lowered a weighted line, paying it out meter by meter until it touched the bottom. Then they hauled it back up. A measurement that could take hours for the deepest soundings. What they found astonished them. The ocean was deeper than anyone had imagined. Life existed at every depth they sampled. The seafloor was not bare rock, but a complex landscape of sediment and structure, populated by organisms that had never been described. The results of the Challenger expedition filled 50 volumes of scientific reports. It founded the science of oceanography, and it raised far more questions than it answered. The story of deep-sea exploration is, in many ways, the story of technology chasing curiosity. Every advance in our ability to descend, to observe, to sample, to measure, every new instrument, every new vessel, every new approach, revealed a deeper world than the one before it. The bathysphere of the 1930s, in which William Beebe and Otis Barton descended to nearly a kilometre in a steel sphere barely large enough to contain them, connected to the surface by a single cable. The Bathyscaphe Trieste, descending to Challenger Deep in 1960. The development of remotely operated vehicles in the 1980s and 1990s. Uncrewed craft that could descend to depths no human vessel could safely reach, carrying cameras and sampling equipment and returning hours of footage from places that had never been seen. And Alvin, the research submersible that has been making dives since 1964, that found the hydrothermal vents in 1977, that explored the wreck of the Titanic in 1986. 50 years of dives. A vehicle that has carried more human beings into the deep ocean than any other craft ever built. Each dive a small act of courage. Each descent into the dark, a reminder of how much we do not know. Chapter 13. What remains unknown. We have spent this night in the deep ocean. We have visited the abyssal plain and the hydrothermal vents. We have met the Dumbo octopus and the vampire squid, and the colossal squid, and the giant isopod. We have descended to the bottom of the Mariana Trench, and returned. And yet, less than 20% of the ocean floor has been mapped with high resolution. Every year, expeditions to previously unexplored regions of the deep ocean return with species that are new to science. Not one or two, dozens, sometimes hundreds. In 2023, a single expedition to an unexplored seamount chain returned with over 100 species, potentially new to science. One expedition, one seamount chain, 100 new species. In a world where we sometimes feel that everything has been discovered, that the age of exploration is over, that the maps are complete, the deep ocean remains. Unmapped, unexplored, full of life we have never seen, full of chemistry we do not understand, full of ecosystems that may hold answers to questions we have not yet learned to ask, about the origins of life, about the limits of biology, about what is possible in the universe we share. The deep ocean is the largest unexplored environment on Earth, and it is here, beneath us, right now, patient, ancient, waiting. Chapter 14. The Ocean and US. Before we sleep, I want to say one more thing about the ocean and us, about what it means that we are here on the surface of a planet that is mostly water, living our brief and complicated lives on the thin skin of land that the ocean has, for the moment chosen not to cover. The ocean is not ours. We did not make it. We did not shape it. We arrived on its shores, geologically speaking, moments ago. Our entire species history, a barely visible flicker in the long, slow story of a body of water that has existed for nearly 4 billion years. The ocean was here before us. It will almost certainly be here after us. It does not know us, does not need us, does not notice, in any meaningful sense, our presence on its surface. And yet, we are made of it. 60% of the human body is water. The salt concentration of human blood is remarkably close to the salt concentration of the ancient ocean. The ocean as it existed hundreds of millions of years ago, when our ancestors first crawled onto land. We carry the ocean inside us. Every time our hearts beat, they push a fluid that remembers the sea. Every time we cry, those strange saltwater tears, we are, in some ancient, chemical sense, returning to where we came from. The ocean is not foreign to us. It is our oldest home. We left it a very long time ago. But some part of us, perhaps, has never entirely forgotten. Final sleep sequence. It is very late now. The world outside is quiet. Let your body settle completely into whatever holds you. Feel the weight of it, the comfortable, solid, trustworthy weight of a body at rest. Let your breathing slow, in and out, in and out, like the movement of tides, like the slow, rhythmic breathing of the ocean itself. Somewhere, right now, 11 kilometers below the surface of the Pacific Ocean, the sediment of Challenger Deep lies undisturbed, cold, dark, silent, the pressure of 1,000 atmospheres bearing down on a landscape that has barely changed in millions of years. Somewhere, a Dumbo octopus moves through the dark water of the abyssal plain. Somewhere, a sperm whale descends, breath held, following the sound of its prey into the midnight zone. Somewhere, Around a hydrothermal vent on the mid-ocean ridge, tube worms sway in superheated water. Fed by bacteria that have never needed the sun, the deep ocean goes on, as it has always gone on. Patient, ancient, indifferent to the hours. Chapter 15. The Midnight Hunters. There is a particular kind of hunting that happens in the midnight zone. Not the bright, kinetic hunting of the surface world, the falcon folding its wings and falling from the sky, the cheetah accelerating across open grassland in a blur of speed and muscle and dust. This hunting is slower, quieter, more patient than we have words for. In the midnight zone, food is scarce. Always. The organic material that drifts down from the sunlit world above, the marine snow, the fallen bodies of surface creatures, the slow descent of everything that once lived in the light, arrives in quantities so small, so irregular, that the creatures of the deep have had to evolve entirely different strategies for finding it. Strategies built not on speed, but on stillness. Not on pursuit, but on waiting. The dragonfish, a creature of the deep mesopelagic and upper bathypelagic zones, has a jaw that unhinges to an almost impossible degree, a mouth that opens so wide relative to its body that it can swallow prey nearly as large as itself, because in the deep ocean you cannot afford to let a meal pass. When food comes, when a creature strays close enough, distracted by a lure, or simply unlucky in the darkness, the dragonfish does not hesitate, does not evaluate, does not decide. It opens that impossible jaw and consumes everything within reach, and then waits again, still, patient, in the dark. The viperfish, Chauliodus sloni, has teeth so long that they extend outside the closed mouth, curving upward toward the eyes in an arc that seems, to human sensibility, almost grotesque. But consider what those teeth are for. Not for chewing. The viperfish does not chew. Those long, curved teeth are for impalement, for catching, for holding absolutely, with no possibility of escape, anything that swims into them in the darkness. They are precision instruments, evolved over millions of years, in an environment where every single meal that escapes may mean the difference between survival and slow starvation. And when no meal comes, and in the deep ocean, often no meal comes for a very long time, the viperfish does what all creatures of the midnight zone eventually learn to do. It slows. Its metabolism drops to a rate that would seem, to a surface creature, almost like death. Its heart beats more slowly. Its movements cease. Its awareness narrows to the single, patient, unhurried question of the deep ocean. Will something come? And it waits. And waits. And the dark water moves slowly around it, carrying its ancient chemistry and its cold and its silence. And somewhere above, the sun rises and sets and rises again. And the viperfish does not know this, has never known this, and waits. Chapter 16. The Language of the Deep. We have spoken tonight of bioluminescence, of the living light that fills the deep ocean like a cold, blue-green version of the night sky above the surface. But light is not the only language spoken in the deep. Sound moves through water differently than through air. Faster, farther, with less loss over distance. The deep ocean is not silent. It is filled with sound. The low, resonant moaning of humpback whales, traveling thousands of kilometers through the deep sound channel, or a layer of water at a specific depth where the physics of temperature and pressure conspire to carry sound almost indefinitely, like a waveguide built into the ocean itself. The clicks of sperm whales, so loud at close range that they can stun prey, so precisely controlled that they can resolve objects the size of a tennis ball from 100 meters away in complete darkness. the soft, almost inaudible crackling of snapping shrimp, a sound that, when added together across entire colonies, produces a continuous background noise across the tropical and subtropical oceans, a gentle static that scientists can hear on hydrophones from miles away. And lower than all of these, frequencies so low they are felt rather than heard, vibrations that travel not through the water, but through the seafloor itself. The sound of the earth, earthquakes, volcanic activity, the slow, grinding movement of tectonic plates. The planet speaks to itself in these frequencies, and the ocean carries the message. And somewhere in the deep water, creatures we do not fully understand may be listening. There is a sound in the ocean that scientists recorded in 1997 and have been trying to explain ever since. They called it the bloop, a powerful, ultra-low frequency sound detected simultaneously by hydrophones thousands of kilometers apart. A sound consistent in some ways with the biological production of sound, but far too loud by any calculation to have been produced by any known animal. The official explanation is geological, a phenomenon related to ice quakes in the Antarctic. But the sound has not been recorded again in quite the same way, and the deep ocean keeps its secrets. Chapter 17. The cold seeps. We spoke earlier of the hydrothermal vents, those extraordinary places where superheated water vents from the seafloor, supporting ecosystems that need no sunlight, built on chemical energy and darkness. But there is another kind of vent ecosystem in the deep ocean, quieter, colder, less dramatic at first glance. Cold seeps. In certain areas of the seafloor, particularly in regions where the ocean crust is being subducted, pushed down beneath another plate, water and methane and hydrogen sulfide seep slowly upward through the sediment, not hot, cold, or ambient, moving slowly, without the drama of the superheated vents. And around these seeps, the same miracle, life, the same chemosynthetic bacteria, converting chemical energy into organic matter, the same tube worms, though here they grow more slowly, in the colder water, but they can live for extraordinary lengths of time. Some lamellibrachia tube worms, found at cold seeps, are estimated to be over 200 years old. 200 years. Living anchored to the seafloor, drawing their sustenance from the slow seep of methane through the sediment, growing perhaps a centimeter a year, patient and unhurried in the cold dark. And around them, the same community of clams and mussels and crabs and polychaete worms, the same improbable abundance in an improbable place. At cold seeps, the seafloor sometimes forms a structure called an orthogenic carbonate, a hard, rocky formation created by the chemical processes of the seep. These formations can persist for thousands of years after the seep itself has ceased, providing hard substrate for other creatures to attach to, creating a kind of fossil reef in the deep dark, a record of an ecosystem, a monument, in stone, to the life that was once here. Chapter 18. The ocean's memory. The sediment of the deep ocean floor is a record. Not a record in the way we usually mean. Not written language, not deliberate inscription, but a record nonetheless. The fine particles that drift down from the surface world, the microscopic shells of foraminifera, the silica frustules of diatoms, the dust carried out to sea by wind and rain, the tiny crystals of material from volcanic eruptions, settle slowly onto the seafloor and accumulate, layer by layer, millimeter by millimeter, century by century. A core sample, drilled from the sediment of the deep ocean, contains, in its layers, a detailed record of the history of the ocean and the climate above it, the ratio share of certain isotopes in the calcium carbonate shells of ancient foraminifera tells us the temperature of the water when those creatures were alive. The species present in a given layer tell us about the chemistry and currents of that period. The presence of volcanic ash layers, thin distinctive bands of glass shards, mark specific eruptions, allowing scientists to date the sediment above and below with extraordinary precision. In the sediment of the deep ocean, you can read the history of the climate going back millions of years. The ice ages and the warm periods between them. The great extinction event. The slow drift of the continents and the changes in ocean circulation that followed. The deep ocean floor has been accumulating this record since before the dinosaurs, and it lies there now, undisturbed, in the cold and the dark. Patient as only stone can be patient, carrying its history quietly, waiting for whoever comes with the instruments to read it. Chapter 19. Returning, gently. It is time, now, to come back. Not quickly, not all at once. The deep ocean does not release you quickly. It does not rush. Slowly, from the abyssal plain, rising. Through the cold and the dark, through the layer where the giant isopods wait, and the sea cucumbers trail their long, slow paths across the sediment, rising through the midnight zone, past the viperfish in its stillness, past the dragonfish and the fangtooth and the vampire squid with its cloak of webbed arms, drifting in the absolute dark, gathering marine snow. The pressure, incrementally, lessening. The cold, very gradually, lessening. And then, far above, the first suggestion of colour. Not light yet, not warmth, but the memory of colour in the water. The faintest blue-green. The twilight zone. Lanternfish descending past you as you rise, going in the direction you came from, following their ancient daily rhythm into the dark. And the light growing, slowly. Blue, then blue-green, then something approaching turquoise. The shimmers of the surface, seen from below. The surface world, shimmering and bright, waiting above you. And then you are through. The air, the warmth, the familiar weight of a world built for creatures like you. Final sleep sequence, extended. Let your body remember where it is. Not in the deep ocean, not in the cold and the dark. Here, in warmth, in air, in a place that was built for you, or that you have made yours. A room, a bed, a particular arrangement of familiar things. Let your breathing find its pace, slow and easy, in and out, in and out, like the movement of tides, like the slow breathing of the ocean itself, somewhere beneath you and all around you, ancient and patient and indifferent to the hours. Let the thoughts that have followed you today, the small ones, the persistent ones, the ones that seem to grow larger in the quiet, let them go. Not by force, not by will. Just let them drift, the way marine snow drifts downward through still water, slowly, without effort, settling, softly, on a distant floor. Gone. Feel the weight of your body, the solid, heavy, trustworthy weight of a body at rest. Your shoulders, your jaw, the space between your eyes. All of it releasing, all of it settling, somewhere far below the surface of the Pacific Ocean, in the deepest part of the Mariana Trench. The cold is absolute, and the dark is complete. The sediment lies undisturbed. The pressure of 1,000 atmospheres bears down, patient and enormous, on a landscape that has not changed in thousands of years. And it is fine. It has always been fine. The deep ocean does not need to be anything other than what it is. It does not need to rush, does not need to improve, does not need to produce or achieve or resolve. It simply is, vast and dark and full of quiet, extraordinary life, going on as it has always gone on, and you can rest in that, in the knowledge that the world is larger than any single day's worries, that somewhere beneath the ordinary surface of things, there is a depth that holds wonders, that life is more stubborn, more inventive, more various, more extraordinary than any single story can contain, that the dark holds more light than you know,